Paging and segmentation. Here is your same structured beginner-friendly content for paging and segmentation, intermediate level, memory management, introduction. Modern operating systems must manage memory efficiently while running multiple programs. Two important techniques used for this are paging segmentation. Both are used to organize memory, allocate memory to processes, improve performance, provide protection and isolation. At the intermediate level, understanding these concepts means learning how memory is divided and managed, how programs use memory, how the OS maps logical memory to physical memory. These concepts are fundamental to operating systems and virtual memory. What are paging and segmentation? Paging and segmentation are memory management techniques. In simple terms, paging means divides memory into fixed-size blocks. Segmentation means divides memory into variable-size logical parts. Example concept. Paging means fixed blocks. Segmentation means logical sections. Why memory management is needed. Programs require memory to run. Example concept. Multiple programs means need organized memory allocation. Without proper management, memory gets fragmented. Programs interfere with each other. System becomes unstable. Paging. What is paging? Paging is a memory management technique that divides memory into fixed-size blocks. Memory equals pages plus frames. Memory equals pages plus frames. Key concepts in paging page. A fixed-size block of virtual memory. Frame. A fixed-size block of physical memory. RAM. Page table. A mapping between pages and frames. Example concept. Page means mapped to means frame. How paging works. Program is divided into pages. Pages are loaded into available frames and RAM. Page table maps virtual memory to physical memory. CPU accesses memory using page table. Example concept. Virtual memory means page table means physical memory. Advantages of paging eliminates external fragmentation. Efficient memory usage supports virtual memory. Limitations of paging. Internal fragmentation. Unused space inside pages. Page table overhead. Slower due to address translation. Segmentation. Segmentation divides memory based on logical parts of a program. Program equals code plus data plus stack plus heap. Program equals code plus data plus stack plus heap. Key concepts in segmentation. Each segment represents a logical unit. Code segment, data segment, stack segment, heap segment. How segmentation works. Program is divided into segments. Each segment has a base address and size. OS maps segments into physical memory. CPU accesses memory using segment table. Example concept. Segment means base address plus offset means physical address. Advantages of segmentation. Matches program structure, easier debugging, supports protection and sharing. Limitations of segmentation, external fragmentation, complex memory allocation, slower allocation in some cases. Paging versus segmentation. Division, fixed size blocks. Variable size logical blocks. View, physical memory view. Logical program view. Fragmentation, internal, external. Complexity, simpler, more complex. Use case, virtual memory systems. Logical memory organization. Combined approach, modern systems. Modern systems often use paging with segmentation concepts. Example concept. Segmentation, logical, plus paging, physical, means efficient system address translation. Both techniques involve translating addresses. Paging address translation. Virtual address equals page number plus offset. Virtual address equals page number plus offset. Segmentation address translation. Logical address equals segment plus offset. Logical address equals segment plus offset. Real-world example. Running a program. Program means divided into pages/segments. Means loaded into memory. Means executed. Fragmentation explained. Internal fragmentation, paging. Unused space inside a page. External fragmentation, segmentation. Free memory scattered in small blocks. Example concept. Paging means small unused spaces. Segmentation means scattered memory gaps. Why paging is more common today? Paging is widely used because simpler implementation works well with virtual memory, avoids external fragmentation. Segmentation is less common but still important conceptually. Concepts learned. Difference between paging and segmentation. How memory is divided and managed. How address translation works. Types of fragmentation. How operating systems handle memory. Advantages of understanding this topic. Understanding paging and segmentation helps. Understand OS memory management. Debug memory issues. Learn virtual memory deeply. Prepare for advanced system design. Example concept. Better memory understanding means better system knowledge challenges. Common difficulties include confusing pages versus segments, understanding address translation, visualizing memory allocation. Example concept. Abstract memory concepts means harder to visualize simple definition. Paging and segmentation. Memory management techniques, where paging divides memory into fixed-size blocks, and segmentation divides it into logical parts of a program. Final summary. Paging and segmentation are fundamental techniques used by operating systems to manage memory efficiently. Paging divides memory into fixed-size blocks, making allocation simpler and avoiding external fragmentation. Segmentation divides memory into logical sections, making it easier to organize programs. Modern systems primarily use paging while incorporating ideas from segmentation. Understanding these concepts is essential for learning operating systems, memory management, and system performance.